right, 4 minutes past the hour. I want to thank everybody for joining us today. We are going to get started here. We've got a great lineup and a really great topic today. There's a lot of interest in this, and I hope it's of value to you. I'm pretty sure it's going to be. This is going to be a really, really good conversation here. So welcome to the Cockroach Hour. This is we're trying to do this every other week. It's more of a free-form conversation where we get technical and in the weeds of some things. But let's not kill people with slides. Let's have a really good conversation about technology and what's going on. And that's really what we're trying to do here with the Cockroach Hour. We've got lots of these coming up. We'll publish at the end. I'll show you some more that are coming up. Talk about topologies and distributed systems, about isolation levels and databases and tricks and problems that can happen. We'll have a bunch of the Cockroach Hours coming up over the next couple months. I'm excited. Our CEO is going to get on and actually talk about serverless. I think that's going to be a really cool one too. So without further ado, I want to get started here. Thank you, everybody. So a bit of housekeeping. Please do ask questions today. This is an open conversation. There is a QA panel. There is also a chat as well. I prefer the chat, honestly, because I like to have the conversation and more of a community. And I know there's a couple of our sales engineers and some of our technical people are on the webinar as well today. And I know they're lurking around the chat, so they may engage you as well and may help me answer some questions if they're happening there as well. And then before anybody asks, yes, the recording will absolutely be available after the event. I know they get pushed out to everybody. They're available on our website, off our webinar page, and I think they're on our YouTube channel as well. So that's all the housekeeping I have. I should jump right into this. Today's topic, today's session is, it's medium to advanced. We have a couple of topics that we're going to cover here, mostly about our cloud report, of which we published, earlier this year. Where we basically go and benchmark all the public cloud providers, running some workloads that are kind of pertinent to our customers. But we're going to talk today about machine types, default configurations of cloud providers, and how to tune and optimize, most notably for GCP. And so let me come back to that. But please do ask questions. I know JP is on the phone with us here today, and for the best questions, we're going to be sending out some swag to some people. So we like questions and we'd like to incent. So please do. We'll send you, I think, T-shirts and some stickers and some other stuff too. But I want to thank the guests today. So I think let's actually go on video, guys. If you don't mind, we'll start that up while I'm introducing you all. So with us today, I have Mr. Steve Deitz. Steve, did I say that correctly? Please say I did.
Deitz, yes.
Okay, because I've been calling you Steve for like a month and a half, and I never even actually had to say your last name until this very moment, right? So, we're real honored to have Steve from Google with us today. He's a software engineer. I'll let him kind of introduce himself and what his role is. What's your role at Google, Steve?
Yeah, so I run one of the cloud performance groups at Google. There are several. And what our group does is we run benchmarks on Google Cloud, and we analyze the performance and measuring both availability as well as performance. Performance being probably that's where we get a lot more metrics of. We do this across all of the products. So from VMs to some of the managed databases to serverless products. So it's a pretty wide breadth. There's many products. The goal is really to kind of drive Google Cloud to being a very high performance platform with high availability. Yep. And one of the more public things that our group does is we also maintain PerfKit Benchmarker on GitHub, which is a cross-cloud benchmarking tool. I'm sure we'll talk about more later.
Yeah, cool. And then we have links to some stuff on that as well, just to give a little foreshadowing what's going to happen. So, Steve, you're like the perfect person for this webinar. We're talking about the cloud report. We think a lot about these things here at Cockroach as well on behalf of our customer. And I'm also thrilled to have Andy Woods join us. Andy and I have known each other for now a year and a half. And I think Andy really spearheaded a lot of the work that we've done here at Cockroach Labs around the 2020 cloud report. So anybody who out there who has actually read the cloud report and they want to complain, you can complain to Andy. Or I guess if you want to thank somebody, that's Andy. So Andy, can you just give a little intro on what you do here at Cockroach Labs?
Yeah, absolutely. Thanks, Jen. So I'm a product manager here at Cockroach Labs. I work primarily in our SQL product area, so all about accessing the database. One of the things we do care about, of course, is performance and making sure that we have good performance. And then, the cloud report now has been something that we've done for 2 years in a row. I think we'll continue to do it this year and well into the future. And it's really kind of a great story about something that it kind of came serendipitously to us. We were doing some of these tests, we were doing some of these benchmarks. Our customers were asking us for advice. How do you get the best performance out of various clouds? And we started running and investigating, and we just got really curious and dug into this. And so we ended up turning that into the cloud report now that we've had for a couple of years. And I've gotten the privilege to work with each of the clouds to talk about how to get the best performance out of the clouds, to dig in. And one of the things that we're committed to is to really try to be good partners to everybody involved in this, but also to, be honest. So one of the components of the cloud report is that we produce all of our reproduction steps. We make them available. You can literally copy them and produce and find the same results that we found. We think that's really important for transparency. We use public benchmarking tools that are available to everyone. So that everyone can kind of go through this. Now, we recognize not everybody has the same time as we do to go out and actually run these things themselves. So that's why we put it up and categorize it and put it in the cloud report. But we want you to have the transparency and the ability to do so if that interests you. And so I'm really excited here to talk today with you both, and to ask Steve questions. We're super curious about all the best practices in Google and moving forward. And I'd say one of the most important pieces of learning I've gathered over the last couple of years doing this is that the results do not stay stagnant. The cloud's making huge investments here to improve things. And so I'm excited to hear what's changed even since we last did the cloud report, and to talk more about this moving forward. So I'm looking forward to it.
It's a phenomenal piece of work, Andy, and I know the effort that goes into it is not small. I mean, benchmarking, choosing machines, going across all the different machine types, running all the various different benchmarks. This is a full-time job. Obviously, this is what Steve does for a living. You're doing it as kind of a side job as a product manager. So kudos to you, buddy. And I think we really do get some great material out of this, and it's something that we're ramping up as we kind of update it for the 2021 report. I'm going to be really happy to get out of 2020. I honestly, you guys. So my name is Jim Walker. I'm in product marketing here at Cockroach Labs. I geek out on this stuff as well. And my job here is just to help the conversation move along. That and troll some Minnesota people that I know that are on the phone today with my White Sox hat. But I'll leave it at that. Welcome, Minnesota. You guys beat us this weekend, but we'll get you back. I'm so happy to have baseball. So, all right. So Andy just did talk about the 2020 cloud report. We do run thousands of benchmarks across all the public cloud providers. And it does outline lots of really kind of great information about what we found. I know we use, default configurations in all the cloud providers. We're going to talk a little bit about that. I think one of the most interesting things about the cloud report and when we publish it and before we publish it, we actually, send our results to the various different cloud providers so they can comment and talk to us about it. I know GCP in particular was incredibly interested in what we had done, and like to the level of like we got on the phone, we started sharing things, and I think we're just a really good application to test the performance of some of these cloud instances, and I think there's been a lot of sharing, a lot of great stuff back and forth. So with that, we've reached out to AWS and Microsoft, and we hope to bring them on to talk about these things too. But obviously, Google just jumped up and said, let's talk about this. So we're really happy to have Steve from the Google team over to talk about some of the things that we did. So with that, Andy, you gave a pretty good overview of the cloud report. Was there anything else you wanted to add? I mean, I think, I don't think performance here is just a report for us. We run performance tests every night, which is kind of one of those key things this is interesting things about Cockroach, right? So
yeah,
this is in our blood, right? So is there anything else you want to comment on cloud report before we get started?
Yeah, I mean, just for those of you who haven't had a chance to read it yet or haven't gone into it, we cover a couple things in the cloud report. We test CPU, we test network, we test storage as sort of fundamental micro benchmarks about the performance. They sort of matter, no matter who you are about these kinds of things. And then we sort of aggregate this up in a database benchmark called TPCC. It's an industry benchmark that's put together with many different companies and partnerships that's really tried just to be sort of a representative set. And this helps explain sort of overall performance, and it's how we kind of got into this, because it's a benchmark we're pretty big fans of ourselves, because we think it's a really good way for us to see how we're doing and see how we're improving as a database and whatnot. And so I think, the main things here to take away out of this is that we try to give you a representative set of what's going on with each of the clouds. We try to test the most recent machine types on each one of the clouds. And we do this not just because we find it interesting, but because it's valuable to our customers as well. And so that's probably a good general overview of kind of what happens here.
Yep. Well, cool. Well, let's get into the conversation. I will let you and Steve go. I know you guys had a couple things you want to cover. There's already a question, which is great. We'll get to it when I think the right timing is. But I love that somebody's already jumping in and like, let's get in it. So I will let you guys just get into it a little bit more deeply. So I will leave you to actually just get rid of slides. So Andy, I know you had a couple areas you want to talk through, right? So I'll just let you go, buddy.
Yeah. So maybe the first thing I want to make sure everybody can learn more information. I think one of the things that we care about here is teaching you, how to learn more information, how to learn more things. And so Steve, I guess my first question for you is, what are the blogs they should follow? Where should people get more information when they want to learn more about Google?
Yeah, there's, thanks, Andy. That's good. That's a good place to start. There have been a couple blog posts recently on performance benchmarking. So one is, and I think, Jim, you have the links, Performance Art, Making Cloud Network Performance Faster, Benchmarking Faster and Easier. And this is a report that introduces PerfKit Benchmarker, but also talks about how to get the best network performance on Google Cloud, along with a follow-up report called What a Trip, Measuring Networking Latency in the Cloud. And so these two blog posts really introduce how you can do benchmarking on Google Cloud well and collect your own data, and then also give a good overview of what performance you might achieve. There's linked into that a dashboard that's public that will show cross-region network latency results between all of the regions of Google Cloud. The other place to look is just kind of in the general documentation. Google's website is organized by solutions. So I had a link to cloud.google.com/docs/tutorials, where you can basically search all the solutions that are available. And that's kind of a good way of saying, okay, well, what do you want to do? Are you trying just to migrate a workload to the cloud, or are you running a high performance computing app? So those are some great places to start.
Awesome.
Hey,
That's great.
Real quickly, you guys could see my screen, right? I don't even, it's like I'm an amateur at Zoom or something. I mean, I haven't like lived my life on it for the past 3 months, right? But right, Andy, you could see the screen?
Yeah.
Okay, great, awesome.
Great.
Never know.
Steve, so I guess one of the things that I think was interesting in the report this year is that we ended up testing new machine types, the C2 and the N2, and we found great performance improvements on those new machine types. I was wondering if you could tell us a little bit more about those machine types for people who are not familiar with them, and then as well as what other machine types have come out since we did the cloud report that are interesting to you from GCP.
Sure. Yeah. So one of the real nice advantages of Google Cloud is, I think, kind of you could summarize it both simplicity and flexibility. So you have the previous, we only had one machine type. You could say, oh, I want an N1. And you could even say, oh, go launch me an N1. And it's going to launch with certain defaults. But that was across several generations of hardware that you could use. So the N1 took us all the way from Sandy Bridge machines up to Skylake machines was the latest platform on that. Mm-hmm. Then with Cascade Lake, we introduced the N2 and the C2. Mm-hmm. So these are two different lines of machine type. You basically get a new machine type. The N2 is going to be a Cascade Lake machine type. It also supports custom machine shapes. So you could take a standard machine shape on Google Cloud, which is about a one vCPU to 4 gigs of memory. But you could also say, oh, I don't need that much memory. I want 16 vCPUs, but I want less memory, or I want more memory. And you can tune it within certain parameters to choose exactly what you want. So the N2 is kind of a follow-up line on a standard machine type. The C2 is a new SKU. It's compute optimized. So this differs from, on N1, we had N1 high CPU, we had N1 standard, and we had the N1 high mem in terms of increasing the ratio of memory to the CPUs. The N2 has that as well. So you could get an N2 high CPU. It means you get more CPUs relative to the amount of memory you have. The C2 has a fixed size, so it's 1 vCPU and 4 gigs of RAM, and it has a different underlying processor, so it's going to be a higher clock rate and just generally, lower core counts. Right now, you can get an N2 up to 80 vCPUs, but the C2 supports up to 60 at this time.
Got it. That makes sense.
Then there are some other machine types that have come out since the cloud report as well. I think one of the first ones, which is now GA, is the E2. And so this is a more cost-effective VM. It goes kind of running your application more efficiently. So especially if you could scale out and use lots of E2s. The E2 only goes up to fewer numbers of CPUs. Okay. And it's custom, so you can decide how much memory you want to get from it. But it's more akin to something where if you need a sustained high performance and you need to kind of consistently hit this, then you're probably better off with the C2 or the N2. But if you need great price performance and you want a lot of it, it's not you can still get pretty good sustained performance, but there's it's run more efficiently than the other platforms. So it's kind of there's a price performance differences between the two. We also introduced the N2D. So this is similar to a standard machine type shape, and it is backed by the AMD EPYC processors, the Rome generation. So a very recent generation of AMD processors. This one goes up to much higher core counts. You can do up to 224 vCPUs, if I remember that number correctly. And on the N2D, just as an aside, there's also a support now for confidential VMs, which we just publicized recently. This is where the memory is encrypted, so it's great for certain use cases. And still has high performance because in hardware, it's exposing hardware support for this. And I know the cloud report hasn't touched on GPUs or accelerators. Google Cloud, traditionally, you have been able to just attach a GPU to any one of the N1s, and you can say, oh, I want a relatively small machine, and I'm going to attach so many GPUs. We've just introduced the A2, which brings the next generation of GPU, the A100. There's also some very high memory machines. So we've had the M1 machines, and now we have introduced the M2, which give, for a higher price point, very large amount of memory, I think up to 12 terabytes of memory. And so these are for specialized workloads. I don't know if you would run Cockroach database on that, but there are some high performance in-memory databases that are useful to run on these machines.
Yeah, that makes sense. I think one of the things.
Very quick overview.
Yeah, I think we could be here all day if you were just to describe all of the various machine types and the permutations that exist out there. But it is interesting that you mentioned the different use cases, right? Because that's one of the things that we try to stress in our cloud report is that we're testing certain use cases, we're communicating information that's broadly valuable and true about the different clouds. But of course, your workload is different than other people's workload, and everybody should sort of be calibrating for the right factors that matter for those workloads. And so we see things like machine learning or other things that are more intensive might need to adjust things accordingly. So it's great that Google is offering multiple different options out there to meet customers' needs.
That's right. Yeah, and even one customer is probably going to need to use a variety of different machine types just to optimize what are they? Do you have a very latency sensitive application, or are you more interested in just the throughput you have? It doesn't matter how long it will take, but you want to pay less money.
Yeah,
and so then you're looking at a more throughput style machine.
Yeah, that makes sense. One of the things I found interesting about GCP's approach compared to some of the other clouds is the modular nature of the machines, about how you can mix and match the storage, and you can adjust all of these different components. Could you talk a little bit more about the sort of ethos behind that, and what kind of configurations exist like that out there on GCP?
Yeah, so one, you can do this. I think this is pretty unique to Google Cloud. Is you can set, at least for large cloud providers, you can set the amount of CPUs and the amount of memory that you want, and you can do such in a pretty much an unconstrained way. And if you're within a certain range, like between our high CPU and our high mem instance, you can really optimize your price point for how much memory you need and how much CPU you need for your application. You can go outside of those ranges, and I think you're paying a premium. There's a use case for that, but it's within those ranges that you really are paying for just exactly what you need. In addition to CPUs and memory, then there's GPUs that you can attach in different quantities to the N1 machines. And then local SSD, where you can specify how many SSD disks you want to run. And so I remember with the cloud report talking about that, and there was one thing that you can do is if you say, okay, I'm going to use that C2 with 16 vCPUs, you can, for just additional cost of local SSDs, attach more SSD disks there and get a lot better SSD performance because you got that. You don't have to pay for additional CPUs and memory on top of that. So I think there's a lot of flexibility into picking the exact size if you can predict it, or you can benchmark it against your application. You can really make a significant price savings there.
Yeah, that's a good point.
I think those are the main ones that come to mind, at least right now, between local SSD and GPUs. As most clouds, for the standard remote disk that you have, most clouds will offer an HDD or an SSD solution, different things. I was reading about PD balanced on Google's cloud documentation now, which is somewhere between the performance you'd see with our remote SSD and our remote HDD, and you can kind of choose different disks, but that's more universal as to flexibility of how many remote disks you would attach to a VM.
That makes sense. I see a lot of questions are coming from the audience about PerfKit, and I think we'll get there in just a second. But before we make the full transition to that, one of the things that was a challenge for us in completing the cloud report is that we want to try to hold as many factors constant as we can across the various different clouds, right? We want to, we don't want to be testing one machine type with more CPU on one cloud than on another, or more memory than another. And that really comes up in this idea around defaults. Like, what are reasonable defaults for the clouds? How do you think about these defaults? If we took the approach in the cloud report with it, we would take the defaults that were available on each of the clouds exactly as they were, so that we could kind of avoid the bias of misconfiguring any particular cloud. But of course, each cloud has these tips and tricks and things that matter depending on the machine type or your workload or other things about this. And so I'm curious, as you start to think about benchmarking and as you think about GCP's defaults, like how does GCP think about these kind of defaults and balance the sort of default setup with the configurable nature that we just talked about previously?
Well, let me answer that from my perspective of kind of doing the performance benchmarking of across Google Cloud products. So we'll look at different machine types, and we want to run benchmarks across these different machine types, and we want to figure out, if I'm a customer and I'm using one machine type, what kind of thing should I be? What if I'm running what? When would one machine type be a better choice than another machine type? And in order to do that, so if you don't use defaults and you really go in and tune, then it always comes back to kind of questions. Well, did you tune that one just as well as you tune this? So like if I were doing N2 versus N2D, the Intel AMD switch, there's a lot of tuning that you could do that's going to be get more specific to those compilers, like what. So for example, with HPL, and this is kind of the benchmark that backs the top 500 list. There are optimized math kernel libraries for Intel machines. There's optimized ones for AMD. If you start to switch and start using those different math kernel libraries, and then if you do, that might be great for scientific computing, but is that still representative? Does it make more sense to just stick with the open BLAS? When you're going cross-cloud, as you are doing in the cloud performance report, I think the challenge is even more sizable. So especially with our N1, you say, okay, we're going to just pick a machine type and then run on that. But the machine type doesn't necessarily embody the same thing on the different clouds. So the N1 crosses a lot of different generations. So we had that flag min CPU platform that you could use in G Cloud to say, hey, I want a minimum CPU platform of Skylake. Yep. This is important for some customers and not important for others, because as these change, as we introduce new platforms, maybe you don't want to keep upgrading or using the latest hardware. You can just say, oh, I want an N1. So there's simplicity in that. Mm-hmm. But if you're then comparing against a later machine type on another cloud, and you're just getting a different platform, then it's not really an apples to apples comparison at that point. The same thing shows up with local SSD in the report too, in that the default in our CLI is to go with VirtIO SCSI as the driver interface instead of NVMe. Now, Google Cloud is one that actually we support both SCSI and NVMe on the local SSD across machine types, which gives customers more flexibility. There are certain reasons why you might want to use SCSI. Maybe it's more widely supported in some images. Mm-hmm. But if you want highest performance, and we have some performance numbers for a local SSD on the what you would expect in terms of IOPS on the Google Cloud documentation site, the NVMe is going to be higher. So if you're using the default of a further machine type on one cloud that just goes to NVMe, then that's something that I would say, oh yeah, you really want to kind of choose those drivers carefully. There's also differences in the guest images between the clouds, where it's like, oh, okay, now which knobs do I have to turn and make sure they're exact as opposed to what should I just take out of the box. I would argue that there's some things that you should take out of the box, but there's a few things even in the guest that are kind of big enough that you may want to look at them as well to kind of level the field, to make sure that you're doing apples to apples. Because if you give advice and say that one machine type, for my case, one machine type is better than the other machine type, and you're just using the out-of-the-box configurations, but there's just a simple switch that you could change on the other one to make it outperform, then that wouldn't be very useful for a customer who could easily just flip that switch.
Yeah, I think that was definitely a learning that we had over the last couple of years, is that, like, it's insufficient to do just perfect defaults as is, because, as you've noted, you could, even I think without specifying, sometimes you could get an NVMe and sometimes you get SCSI, or you could sometimes get Skylake and sometimes get a different processor, right? So, we want to be consistent and scientific and making sure that the thing that we're testing is not, that we're not accidentally testing something else in comparison. And I think so for us this year, one of the things that we plan to do is we actually plan to produce a test plan early and share it with each of the clouds for feedback, primarily because we want to make sure that we're giving each of them the chance to tell us about these knobs and tuning things and things that would be available to their customers or knowledgeable to their customers. So we're taking those into consideration as we're making the benchmark, and that, we're still going to do, we're still going to be unbiased. We're still going to hold things, as consistent as we can across the clouds. But, it's really important for people using GCP to know that they can have control over their machine types, and that we want to put that forward and make that front and center.
Right. Yeah. Well, looking forward to seeing the test plan, and I'm sure we'll talk about that in some detail.
Yeah. Hey, Andy, I got a question on that actually. Where do you stop? Right? Like, because I think customizing any one of these, there's so many instant types. There's, we're gonna do 3 cloud providers, right? How do we what's the line do we draw in terms of, because you could performance tune, you can optimize these things for, gosh, guys, a long time, right? Like, how do you see us getting a balance there, Andy? Because I think everybody runs into that too, right? You only have so many hours in a day.
Yeah, I think it's a great question, and it's something that we struggle with a lot, right? Like we want to be thorough and we want to be, representative and useful, but at the same time, we all have day jobs here too, right? Like I think you could have an entire company the size of Cockroach Labs devoted to producing a cloud report and still not test everything that would be meaningful, right? Things that we haven't tested include, the time of day. We haven't tested much about the different regions or availability zones. There's lots of things like that I think you could test. Yeah. What we try to do is we want it to ultimately be useful to our customers. Now, we want the report to be broadly applicable and to be informative of the clouds, but one angle of that is we focus on things that we're actually going to be running in our Cockroach Cloud environment. So what are the machine types that are going to be available there? What are the sizes? Right. We also look for things that we know our customers are using, right? So we're constantly talking to customers about the machine types they're using, how they're configuring, what they're setting things up. We want to, be testing the things that they're trying out and using there. But this is an example of, despite this being a scientific report, it also is an art, right? Finding that balance between the being meaningful to others, but also, capping it and holding it at some level of investment from ourselves.
I think we have all three ranges of people who would actually tune. There's me, I'm just going to spin up an instance, use it how it is. There's Andy who's going to get into it. And then there's Steve, you have your whole life dedicated to this thing. You know what I mean? Like literally I have all three types here, but I think it's important because I think, some people just want to get up and running. Like what are the simple things they can look at? And I think the Cloud Report does a decent job at that, right? And I think that customizations get really tough. And I think it was the very first conversation we had with y'all, right, Steve, at GCP. Like when we first published, it was like, wait, you guys use default configs, right? So it's tricky. Yeah. It's real tricky. So, but we want to be fair too. So.
And I do think on that point, one of the things that's kind of interesting is, we know that a lot of people use scripts to provision, right? And so I think that was one of the ideas behind holding the N1 name constant is that people have these scripts and they don't want to necessarily have to update the scripts, but you could, improve things behind the scenes. And I think that what we found is that there's a balance between that and doing everything possible to get the best possible performance. But so maybe this is a good place to transition a little bit, Steve, why don't you tell our audience about PerfKit? What is it? How does it work? Let's talk a little bit about that.
Yeah, so there's a GitHub page for PerfKit Benchmarker that I recommend now the best way to really get started with PerfKit Benchmarker, maybe I'll mention this again, is the tutorials. So you have to, it's basically a GitHub page, but there's a tutorials directory. We really need to put a link to it at the very start because the tutorials will tell you kind of how do I actually install PerfKit Benchmarker and actually get up and running with it. And it even allows you to do it through a cloud shell on Google Cloud, just at a free tier to test it out. What it is, though, is a kind of a cross-cloud benchmarking tool. So you can run the same benchmarks on different clouds, and you still have to decide what you're comparing. So it doesn't have kind of set comparisons in there. But you can say, so I'll give you an example of going into a benchmark. There's a CoreMark benchmark. And so you can write as a command line as simple as pkb -- benchmarks equals CoreMark, cloud equals GCP, machine type equals C2 standard 4, right? You could say those, and then zone equals US East 1B. So you basically are specifying, at a minimum, I like to specify the machine type, the zone, the cloud, and the benchmark I want to run. And what PerfKit Benchmarker will then do is it will go ahead and it will, using your DOT files and your credentials to actually create VMs, it will use gcloud to spin up a VM in that zone. And then it will use the command line SSHing into the VM. It will do everything it needs to set up the OS, set up the image, install whatever packages it needs to support installing the benchmark CoreMark. It will install CoreMark directly from its GitHub page, compile it, run it, and then go ahead and publish the numbers. The numbers get published. There's kind of a variety of default publishers. I think the default is really just to spit out a CSV file that has it. So it's not, you're not running it and then publishing data anywhere. You can specify, oh, I'd like a BigQuery publisher, and you publish it to your own kind of BigQuery instance. Or you could say, oh yeah, no, just show me the results in a CSV file. And then it will go ahead and tear down the VM and delete all the resources. That's by default. You can also run it in such a mode where you just say, oh, I want to just provision, prepare, and run. And then it will leave the VM up and running. And you can actually SSH into the VM. You could rerun the commands. It's all set up for doing that. It also supports numerous flags to try to make try to let you look at differences between OS types, differences between machine types, and differences between the clouds in a more fair way. So one flag that I'm pretty familiar with is the enable transparent huge pages flag. So transparent huge pages in OS image, especially in a virtualized environment, can be very critical to performance. And the defaults in some clouds might have a transparent huge pages off, and in some they might be on, even with the same OS image, like the latest Ubuntu 16 or Ubuntu 18 image. And so that's an important one to say, yeah, you know what, I actually want to make sure that I'm using huge pages in the same way across the different clouds. The tutorials that I was talking about one tutorial will kind of talk about, oh, how can you use PKB to do some basic networking benchmarks? And it talks about netperf and ping, which are supported. It also supports Windows benchmarks like NUTTCP, in which case you are launching a Windows VM into the cloud and then running on that. And there, of course, we're not SSHing into Windows. We're using WinRM and running commands on the Windows VM. So we could set up kind of Windows tests as well. So the tutorial will walk you through using ping and netperf on a GCP VMs to do VM to VM latency within the same zone, or VM to VM latency across regions. And while ping might be fine, you could read the blog post for more details, ping might be fine for across region. We usually recommend something like netperf, where you're keeping the host very busy to do the networking benchmarks between zones, because you can get some pretty impressive VM to VM networking times now by kind of following a few recipes to get that. So there's some information on our blog post. And I'm going to I'll go on just a little more here. There's also a solution. There's and I think I shared the link for this. This is best practices for using MPI on Compute Engine, or kind of best practices for running tightly coupled HPC applications. And I'll spend just a minute, because I saw one of the questions in the chat go on about this. Is that, what do you have to do if you really want to get low latency numbers between there? And even with TCP/RR, following some of these best practices are there. First, we recommend the compute optimized machine, the C2 there. Then there's a feature on Google Cloud, and this is what I saw in the chat, called placement policies. So you could say, oh, I want a compact placement policy. It applies to the C2. So you can say, I want two C2s, and I want them not only to be in the same zone, but I want them to be really close together, because I'm going to be doing a lot of tightly coupled communication between them. The other kind of placement policy is where you say, oh yeah, I really want to spread these out, so that if something big happens in the zone, like maybe the whole zone doesn't go down, but some hosts go down that are nearby one another, it's often the case, oh, I want to put them in a placement policy that will spread them out. But for a latency number, if you're on some HPC application, compact placement policy is going to get those really close together. And then one other, just aside here too, because it's in that solutions article, best practices for tightly coupled HPC applications, is you can go into the guests and you can actually turn off meltdown and specter mitigations. And so whenever we talk about turning off security mitigations, we have to kind of really caveat it with, you shouldn't turn off security mitigations unless you really know what your applications are doing. But these mitigations deal with if you have a multi-tenant solution in your VM and you're running processes that shouldn't necessarily see one another, then you shouldn't turn those off. but there are already, there's mitigations on the host side. So if you've got your VM and you're running an HPC application there, you should check, but it might be okay to turn those off. And again, these security mitigations might not be the same across the clouds on in the different kind of default guest images that you get. Yeah, there's a big list of everything you could do to really kind of optimize your latency and get it down to more in the tens of microseconds between VMs that are just in the same zone.
Yeah, that makes sense. I think we'll dive into that here more in a minute, but there were a couple questions that came in the chat around PerfKit. So one person was asking, what kind of, do you need IAM users? What kind of like credentialing do you need to set up to run PerfKit? Is there anything special anyone needs to have to use this?
Well, you do need an account on the cloud in which you're running, and then it's all run through a command line interface. So gcloud or AWS CLI or AZ for Azure CLI, and there's some other clouds and supported as well. So you need an account, and then you need to be running in the user account that has permissions to run those CLIs. But other than that, it's all through the CLI. So you're basically just, PerfKit Benchmarker is really just a script that runs on top of the CLI. So you set up your account, and then you can use PKB on top of that. Now it's going to provision resources that will cost real money as they're left. And PKB does a pretty good job of tearing down. But it's always possible that you're run PKB and then the power goes out on your laptop and you don't get to the teardown stage. You know, you'll have these provisioned resources. You should look at it. It's saving them, so you could actually pass it the same run URI and say, okay, run the teardown script on that. But you should be aware of what resources it's launching, so you could go onto the Cloud Console and delete these as well.
Yeah, that makes sense. I feel like every few months we find about a couple of resources we thought we'd tear down and we'd forgotten about it. So I'm sympathetic to that.
Right.
There were a couple other questions here. Is there any kind of testing with containers, or do you have any plans to extend PerfKit to test around containers, or how do you think about that?
Yeah, there is support for Kubernetes, and there's some support for Docker as well. So you can run some benchmarks against a managed Kubernetes like GKE, and so then not all the benchmarks will work, but some of them like Spec or NetPerf, you could say, oh yeah, I'm going to want to run this, and instead of being on two VMs in the same zone, maybe you say I want to be in two Kubernetes jobs, right? Just launch me off and create a Kubernetes cluster, and it will do, again, it does the provisioning, preparing, and setting up of those instances, runs the benchmark between them. There's some support, and it's detailed in one of the networking blogs, of actually doing a NetPerf measurement where you want to kind of run a Docker container locally and do NetPerf between your machine and the cloud. This is a little more difficult to use with PKB. I'm amazed, like there's definitely sophisticated users out there who have gone and used PKB and can read it and understand all the documentation, which we're working on. And because you could set up static virtual machines where you're essentially just giving it an IP address. And so instead of provisioning a VM in a cloud, you could say, oh, I just want to go ahead and use the static VM. And so now you can run it between an on-premise or some VM in your own data center and Google Cloud, provision via VM and do some networking between it. Yeah, I think that kind of covers container support.
Yeah, that makes sense. How regularly do you run PerfKit type benchmarks internally? Do you run these nightly, weekly? What kind of stuff do you guys test in your group as a regular basis?
Yeah, so we run these continuously. I'm pretty sure that if I would log on right now and look at see how many benchmarks are running, I'm guessing there's probably tens or hundreds of these running now. So we run extensive. We have a lot of different machine shapes and machine types. And I know the cockroach of the cloud performance report, right? You really have to say, okay, I'm gonna pick a machine, and you picked 16 vCPUs because you can find a 16 vCPU machine in that configuration kind of across all the clouds. And then you just get it close enough because you can use custom memory on Google Cloud. I don't think you actually use custom memory to match exactly the Azure or AWS, but you can pick machine types that are close enough, right? Let's say, oh, let's use the same number of CPUs. You can, we run it across all of the machine shapes and all the machine types, and then pretty extensive number of benchmarks. So a lot of micro benchmarks. NetPerf we're running all the time, and FIO for disk performance, running that all the time. And then we want to run that across all of our different disk types: local SSD, remote PD, both SSD and HDD, across the different machine types too. What different machine types or different machine families using these disks? We want to cover them all and kind of look at performance across all these, both for studies and analysis, so that we could see kind of what machine types would you use, but also for just benchmarking performance over time and making sure that we have stable performance.
Yeah, that makes sense.
So lots of tests. We do another test that I'm fond of is a cluster boot test. So this is one of the tests in PerfKit Benchmarker. PerfKit Benchmarker actually, it mostly wraps industry standard benchmarks. So there's very few benchmarks that are actually written for PerfKit Benchmarker. One of them is cluster boot, where we're actually timing the amount of time it takes to provision a VM. So it grabs its metric actually not from the run stage of the benchmark, but from the provision stage of the benchmark. It provisions a VM, and then we run barely anything on that VM. We just return that kind of, how long does it take from when you do the gcloud create command to when you're actually able to SSH into the VM and run something like host name. There's a lot of ways to measure boot. So we usually like to say, not only how long will it take to connect to the port on that VM, to the SSH port, but how long will it take to connect to the SSH port, actually SSH in and run a command and get a result, because then you know, okay, this VM is up and running.
Yeah, that makes sense.
A lot more benchmarks too, but
I'm sure that we could keep everybody busy, but we'll move on from here. But we definitely encourage everyone to give PerfKit a chance and try it out. One of the questions from the attendees here, and it's something we think a lot about at Cockroach as well, is how do you think about the relative performance differences between like an ephemeral and persistence disk? You know, how do you test for those? You know, which do you kind of, you know, we think a lot about which are we recommending to our customers, what kind of guarantees can you get from them? Could you talk a little bit about the differences between them and Google and kind of what you get or don't get, and how you think about the performance around them?
Yeah, so I think we even go so far as to put into our storage product line, right, is the persistent disk, which is going to be a remote SSD or a remote HDD. And when you attach one of these disks to the VM and you look at, you kind of look at what you're getting, it's not comparable to a disk just attached to a machine on an on-premise or kind of in data center setup, because it's actually replicated across multiple hosts in a zone. And so that's persistent disk, and there's different options there, right? So the SSD is going to have lower latency and it's going to be able to support higher IOPS. The HDD, the kind of older magnetic disks, that will have, you can get a lot of throughput there, but for a latency side, if you really need to read disk quickly, then you're better off with PD SSD. It's a price performance trade-off. There's also local SSD. So local SSD is where we expose an SSD device to the VM, and that SSD device is on the same host. And so there's, if the host goes down in a catastrophic way, I don't know, any number of things can happen, your VM is going to restart, and it's going to restart. So there's a best effort to try to restart on that host. We restart you on that host, And this is different. I'm trying to talk a catastrophic failure, not just rebooting the VM. If you reboot the VM from the guest, you'll be right back on the same host. You're not going to lose what's in the local SSD. But if something really bad happens and that host is just out of commission, there's some kind of hardware failure there, then you're going to start up on a different host, and so you're not going to have that same local SSD data. So that's really the trade-off, because local SSD will give you higher IOPS and higher throughput, much higher IOPS and throughput than PD SSD. But it's not, it would be a problem for a high availability app.
Yeah.
So let me have one other quick note is that I think this is somewhat unique to Google Cloud, is on top of zonal PD, you can actually do regional PD, where you have a disk and it is replicated not only within the zone, but also in another zone in that region. And then you have this is an option. If you're talking about building up a high availability app, and you have multiple VMs in a zone, and then maybe even you say, oh, I really need to be in multiple zones of a region, and you have your VMs and your servers running there. Regional PD is something where you can say, yeah, you know what, I'm going to get that replication maybe at a reduced cost by just using regional PD, where the disk is actually in different zones as well.
Yeah, that makes sense. Yeah, it's quite interesting to think about with the availability and availability versus performance trade-offs and whatnot. One thing that we think about at Cockroach is we replicate data multiple times. So is it acceptable to use SSDs with a higher level application that's replicating data in multiple places, and how do you make these kinds of trade-offs? So it's always an interesting conversation for us. I think we're getting close to the end of the hour here, so maybe I'll ask you with one last question, which is, what are the most important knobs, things that people should be on the lookout for to get the best performance out of GCP? What's your general advice for people who are really concerned about tuning their workload? Should they be tuning this before they start on their application to find the right machine type, after they deployed? What is sort of your general recommendation for how to get the best performance out of GCP?
Yeah, right. So that's a big question. Of course, if you can use benchmarks before you deploy your application, that's great. But there's and there are some benchmarks that really try to mimic real workloads. Right? We have some database scenarios or some HPC benchmarks in PKB that you can run. But there's not necessarily a substitute for your application or for a custom benchmark that's really tuned from your application. Right? Like Cockroach Labs, right? You have that Cockroach database that has a benchmark associated with it, and that's great, right? Because then you can just say, okay, I want to provision up my benchmark that's really showing this is what performance I get from my application. And then you come to GCP, and now you are confronted with a wide array of choices, right? You have different machine types, different machine families. So that's a big decision point right up front. Then within a different machine family, then the important stuff is machine size. How many vCPUs do I want to get? Can I scale out rather than just scale up? Do I have to use the biggest VM, or can I use many smaller VMs? So those are kind of some of the trade-offs. Then within there, I guess coming back to kind of the cloud performance report and just making sure we cover those, right? It's important to use the same OS type. That way, if you're doing any kind of comparison between different machine types, then you want to use Ubuntu 18 on all of them. It's important to make sure you're using the same local SSD driver if they're supported. So you want to do NVMe across. For remote disk, you want to make sure that you're not comparing when you attach a persistent disk. I think there's a default for whether it's going to be HDD or whether it's going to be SSD, and so you want to make sure that you're using SSD if the disk latency is going to come into place. If you're doing networking performance and you can use a compact placement policy, you should do that. And then there's a number of guy kind of touched on the transparent huge pages. Some applications benefit from disabling hyperthreading. I'd point you to that kind of tightly coupled HPC applications best practices document, because it looks at it looks at some important knobs that are not that won't only affect HPC. They'll actually get you a boost of performance on other applications as well.
Awesome. Well, thank you for that advice. We really appreciate it.
Yeah, thank you. Wow, it looks like we are out of time. Yeah, thanks for hosting this and discussing it.
I do hope it was valuable for everybody. I know we just man, the top of the hour just came quick, dude. It was like I had 15 minutes, like next thing you know, it's like here. So, Steve, thanks again for joining us. Andy, thank you. That was the easiest session I've ever been on. You just ran that, buddy. Thank you so much. Like, usually I'm in here, I'm like working questions in there. That was great, dude. I was able to just listen and kind of like monitor in the background. So thank you both for taking the time today. It's a great session, and thank you everybody for joining and sticking around for the whole hour. We do hope this was valuable for you. If there's any further questions, we'll go through everything and make sure we answered everything and get questions out to people. Again, we'll give awards for the best questions in there. I think somebody's asked a couple different questions there. But go forth and benchmark your instance types. You know what I mean? So it's fun. I mean, Steve made it his life. Andy loves it. I don't like benchmarking, man. So, anyway, I'm honest. So thank you guys.
Yeah, thank you.
Yeah, thank you.
All right, Steve and Andy, again, that's great. And thanks everybody for joining. Last thing, let me just do one last thing. Please do go check out the Cloud Report. If you have not downloaded it, you're looking for it. It is available on our website. There's a quick little link there, y'all. It's pretty cool and it's pretty valuable. We'll be doing more of these cockroach hour sessions over the next couple of weeks. We're going to be talking about database topologies next. We're going to talk about isolation levels in a database. It's kind of one of these unwritten things that people don't always think about. Do you know what a dirty read is? Do you know what a phantom read is? Do you know what repeatable reads are? Do you know why these things cause issues in your data and why you might be losing money and why casual consistency? I love the word casual consistency, by the way. Might be bad for you. I think the whole point of a database is it needs to actually keep data. So we're going to be talking about those things as well coming up here in August as well. But with that, thank you, everybody, and have a great day.